Hi, good morning. My name is Daniel, and we are going to talk about a SCADA system for thermal monitoring here. So I think you may know the importance of energy consumption, and everybody's talking about a responsible energy consumption. I think you may think about, and you may hear about little tips like the ideal temperature for climate control is around 21 degrees Celsius, or maybe the one that switch off the light if you are the last one in a room. Nowadays is a very common topic, and we want to contribute with that. So we want to build an Erlang efficient system for thermal monitoring. And we want to write it in Erlang. And you're probably wondering why we wanted to write it in Erlang. Well, in this presentation, I'm going to show you our system and why we think this system fits perfectly in SCADA systems. So, what's a SCADA system? A SCADA is an acronym for Supervisory Control and Data Acquisition. They are made to remotely monitor and control different kinds of industrial processes, usually operating with a lot of different devices. So that's the theory. But in our case, what we're talking about? We're talking about thermal monitoring. So we're talking about climate control installations. When we talk about climate control installations, we're probably thinking in something like this. The typical air conditioner that you have in your house. And that's true, but that's not all, because our most usual user wants something like this, much bigger. So we have a very big and complex installation with a lot of devices, such as thermal sensors, air conditioners, etc. So what we want is to build a system able to monitor and control all these types of systems. So here is the big question. Why we think Erlang fits perfectly with this kind of system? Well, as I was telling you, we need to be able to handle a lot of devices, to connect all the devices and to monitor them. So we need to be able to create a system that needs to handle a lot of concurrency activities. And with Erlang, we have the chance to create a very lightweight concurrency system. With Erlang, we are also able to create one node per installation. So this way, we can gather all the information that we have in that installation, and even more, we can have a lot of processes running in the background, periodically running and gathering all the information for making a data history with all the information that we have. So if this grows very quickly and we have a lot of new installations, we can dynamically, with Erlang, create new processes for that instance. And if, as I was telling, if this grows very quickly, we can move all the new processes to another Erlang node or to another machine. So Erlang gives us a very well-balanced horizontal scalability. If one of these parts dies, no matter the reason it dies, if it's an Erlang error or a communication error, we have the chance to only restart that part of the system. And the rest of the system is still alive, so we don't have to shut down the entire system and restart it all again. So we have a very high availability. And finally, soft real-time system. So with all the data that we have and we gather from the installations, we want to build an data history, and we want to show it to our final user. We want to give some feedback to our final user. So we want to show some charts and show some analytics with all the data that we have, but that's not all, because we also want to show real-time information. For example, we want to know the current consumption of an installation, or maybe the current temperature of an installation. And here, the soft real-time ability of Erlang fits perfectly for our system. So this is the architecture of our system, what it looks like. And so in one side we have a lot of installations with a lot of devices all around the world. And in the other side we have our SCADA system with a lot of Erlang nodes. And we are using MongoDB as database. We have all those Erlang nodes connected to MongoDB to save all the data that we have and to create that data history. We're using MongoDB as our database because later, with all that data history, we want to create some kind of data meaning of all that information. So we want to integrate another systems for that data meaning. And also MongoDB gives us the chance to create a sharded database. So MongoDB also give us a well-balanced horizontal scalability. It contributes with our well-balanced system. So nowadays, what we have, we already have implemented an Erlang full stack web application to show our user all the information, because we want that our information be available from any part in any device. So we build a responsive web application, and in Erlang, because as for the same reason as I told you for the SCADA system, we want to create a very lightweight system for our web application too. So we are using Erlang full stack. So we are using MachiWeb as web server, and early DTL as Erlang framework for render all the HTML templates. Actually, right now we are able to communicate with one installation that we are using for testing, and we can gather the information that the installation has. And even more, we now can see the current temperature or the current consumption, so we can show in our application the real-time information. We also have developed another manager for our maintenance system. So if one machine dies, it emits an error signal that we can catch. So in real time, so we can create an alert to our technicians so they can give a better maintenance and a quicker and a faster maintenance to our users. And we also have developed the back end of the service that creates a process per installation. When we have a new installation, we have the new process that gathers all the information from that installation. And we integrated MongoDB with our system using a 3D party Erlang MongoDB driver. So this is what our system actually looks like. This is the overview of an installation. So here we can see the actual information of the installation, and we can see that we define the different zones in that installation, and we can see the current and the desired temperature for each zone. If we click in one of those zones, we can see more detailed information, and we can see for each device all the detailed information for that device. And also we can have live charts to show, for example, the temperature that it has on all day long. And finally, future work. What's left? So as I was telling you, we are able to gather information from an installation, but we are not able to control it. And we need to be able to control an installation because we want to turn on and off all the devices, or maybe we want to reach the desired temperature that we want. We need to be able to communicate with a lot of installations, not the only one that we are using for testing. We need to know how many process can we allocate in an Erlang node. So, and how many shards we need to create for have a well-balanced system. And we need to create all the data history that we need for later do that data meaning. So right now we are gathering information and we are showing it, but we are not saving it in the database. So we need to create all the schema of the database to create that data history. And finally, we want to integrate our system with an intelligent system. And this is the key of our efficient system. Because the intelligent system is going to give our final user some good tips to give a better control of our system to be more efficient. So for example, it can give a tip to our final user, like using the best way of connect all the devices and turn it off. So we finally are implementing an efficient climate control powered by Erlang. So I think you maybe have some questions.
Do you have or are you planning to use your software in industry?
Yeah, we are actually working with a company. So they are the ones that contact with us to create that kind of system.
Sounds like yes, can I have more questions? So another question is, you thought that you want to notify the operators, right? So if something goes wrong, then you want to alert them. And you're now working on a tool that will alert the operators. Have you checked Erlang or SASL, alarm logger in Erlang? Because these are...
No, actually, we didn't check that. Maybe it's good that we can check it.
Yeah. I mean, if there are tools like you should not reinvent the wheel, let's say.
Okay. Thank you.
Further question, please.
Yes.
I think we are a bit preaching to the converted here. So the question is, what is challenging or difficult, or what would you like that Erlang had better support for, or what is the difficulty here?
Well, it's a good point. It is difficult. I actually think that there is no very difficult one. We are just developing the system as we first thought about it, and I think the most difficult part is creating the intelligent system and integrate it with our system. So what we want to do is only monitor all the devices and have the control on it. So maybe the most difficult part is that we have a very large number of installations, and that has a lot of devices in it.
If I may add something. Daniel was very quick there, but I think that one of the key points that could have been difficult was the communication with the PLC, with the devices. We were lucky enough to find a driver, this mod tools TCP driver, that we are using right now only for reading, as Daniel said. So once we start trying to write there, and we still had to do some modifications to the driver for the things that we wanted to read from the devices. So we will see once we start controlling them and actually activating them, if we need to further develop that driver. The other technical
For the energy management policies and control, are you planning on implementing those algorithms in Erlang, or some other language, not to lead to Costas' talk later on
So
today?
are we planning to? I didn't understand.
Oh, so
for
for the actual energy management policies for the later remote control, the decisions for how to do that remote control, I assume, could be implemented in Erlang or in something else. So what is your plans for implementing those?
We want to implement the entire system in Erlang. So later, when we go ahead with our project, you can be able to control from our web application all the devices. So I don't know if that's the answer of your question. So.
Well, usually it's a human interacting with the web app, but I was imagining sort of an internal or a feedback loop that would not involve a human, that would be making some sort of automatic choices.
Yes, but we also want to let the user the final decision. So if they are tips, the intelligent systems only give us tips, and the final decision is on the user.
So, have you performed any performance evaluation, let's say load test, stress tests on your system, or
no, right now we didn't have.
Okay, so we have challenges.
Yeah, we have to.
So you made a good argument that Erlang was well suited to programming SCADA devices, but one thing you didn't cover is security, which is a key issue with these devices that control some very important aspects of our lives. And the Stuxnet exploit is the famous example of a SCADA security failure. Can you comment on how Erlang can deal with the security required by SCADA applications?
Well, actually, we have to check it. We just started implementing our system, and we didn't reach all the points that we have to. So it's a future work, but we also have to check.
I encourage you to think fairly seriously about it, because if you speak to the unconverted about controlling SCADA devices, security is a very real issue.
Okay, thank you.
Questions? Further questions? Thank you very much.